Okay, section 7.7. Equations with rational expressions. Okay, so this is similar to the last section. It's also similar to things we did back in chapter 2. So let me do on page 279, 297, page 297, problem number 2, 5x over 6 minus 4 is equal to 2 over 3. In exercises 1 through 46, solve the equation for the given unknown. So we've actually done these back in chapter 2. In chapter 2, what we did is we just multiplied both sides of our equation by the least common denominator, which in this case is 6. And so let's do that. 6 divided by 6 is 1, times 5x is 5x. Negative 4 times 6 is negative 24. 6 divided by 3 is 2, times 2 is 4. And so now we no longer have any fractions, and so we can solve it. Add 24 to both sides of my equation. And so 5x is equal to 28. Divide both sides of my equation by 5. And so x is equal to 28 over 5. And I never divide by 0 when x is 28 over 5. So this is my answer. And I'm done. Let me do problem number 4. 2x over 5 minus 3 over 4 equals 7 over 10. And so I want to look for a common denominator. And so in this case, I have 5, 4, 10. So the least common denominator in this particular case is 20. Let me multiply both sides of my equation by 20. 20 divided by 5 is 4 times 2x is 8x. 20 divided by 4 is 5 times negative 3 is negative 15. 20 divided by 10 is 2 times 7 is 14. Let me add 15 to both sides of my equation. And so 8x is equal to 29. Let me divide both sides of my equation by 8. And so x is equal to 29 over 8. I never divide by 0 when x is 29 over 8. Therefore, that is my solution. Let me do problem number 8. 7 over 4 minus 2x minus 5 over 7 equals 3x minus 2 over 7. Let me multiply both sides of my equation by the least common denominator. Well, I have a 4, 7, 7, so least common denominator is 28. 28 divided by 4 is 7, times 7 is 49. 28 divided by negative 7 is a negative 4 times 2 is negative 7, so 28 divided by negative 7 is a negative 4 times 2x is a negative 8x. 28 divided by negative 7 is a negative 4 times negative 5 is a positive 20. 28 divided by 7 is 4 times 3x is 12x. 28 divided by 7 is 4 times negative 2 is negative 8. Combine like terms. 49 plus 20 is 69 minus 8x is 12x minus 8. Add 8x to both sides of your equation. Add 8 to both sides of your equation. And so you get 77 is equal to 20x. Divide both sides of your equation by 20. And so x is equal to 77 over 20. And that is your answer. Let me do problem number 12. 3 over x minus 1 over 5 equals 2 over 5x. And so let me multiply both sides of my equation by least common denominator. Well, x, 5x. The least common denominator is 5x. And so 5x divided by x is 5 times 3 is 15. 5x divided by 5 is x times negative 1 is negative x. 5x is canceled, so you get equals 2. Subtract 15 from both sides of your equation. And so negative x equals negative 13. Divide both sides of your equation by negative 1. And so x is equal to 13. When x is 13, you do not divide by 0. So notice when x is 13, I have 3 over 13. That's defined. That's good. I have, when x is 13, 5 times 13 is 65. Again, I'm not dividing by 0, so that's fine. So notice that if x were 0, then I would have to exclude that. Oh, you could multiply by 5x squared, but that's not the least common denominator. That is a common denominator, but not least common denominator. Remember, when you have a list, x, 5, 5x, maybe I'll write it this way. So I have a list of factors. And so to find the least common denominator, you'd say, well, what's the lowest power in this list of 5s? Well, 5. In this list of x's, x. And so the least common denominator in this case is 5x. Is that clear? Yeah. Okay. Let me do. So the important thing in this particular case was to notice that if I came out and I solved this and I found that x were 0, then that would not be a solution to the original problem. That would be what's called an extraneous solution, and you would need to exclude that from your solution set. So you always have to check if you have an extraneous solution for these types of problems. If you multiply by 5, yes, you get 25, yes, but you're dividing. Okay, I'll explain this again. So, actually, let me just write it here, then maybe I'll erase it. So 3 over x times 5x. Let me write it over 1. Well, 5x divided by x is 5. X divided by x is 1. And now you get 3 times 5 is 15. That's how you get this first term. Negative 1/5 times 5x. Again, let's write this over 1. 5x divided by 5 is x. And, well, 5 divided by 5 is 1. And so now you get negative 1 times x is negative x. 1 times 1 is 1. So here you get negative x. And lastly, 2 over 5x times 5x. The 5x's cancel, so you just get 2. Okay, yes. Okay, let's do problem number 20. X plus 1 minus 2 over x equals 0. So in this case, the least common denominator will be x. And so let's multiply every term by x. And so x times x gives me x squared. X times 1 gives me x. The x's cancel, so you just get minus 2. Now, factor. Well, it's a monic polynomial, so I can factor this easily. Bring down the plus times minus. I want to find two whole numbers whose product is 2 and whose difference is 1. Well, 2 and 1. Set each factor to 0 and solve for x. Subtract 2 from both sides. Add 1 to both sides. And so x is equal to negative 2. X is equal to positive 1. When x is negative 2, well, I don't divide by 0. So this is a solution. When x is 1, I don't divide by 0. So again, that is a solution. So in this case, I have two solutions. Let me do problem number 28. Two x minus 3, 3 x squared minus 9, 4 x plus 3. And so let me factor. I can write x squared minus 9 is the product, the sum and difference two terms, using the special product formula, the difference of squares. So this is x minus 3 times x plus 3. And so I can multiply and divide both sides of my equation by the least common denominator. In this case, the least common denominator is, well, we have x minus 3, we have x plus 3. So it's x minus 3, x plus 3. The x minus 3's cancel. So you just have 2 times x plus 3. The x plus 3's cancel. So you just have 3 times x minus 3. Oh, you stupid. Start that again. You have x minus 3's cancel, x plus 3's cancel. So you just have 3. Yes, so whatever possible. Always factor the denominator. You don't have to worry about the numerator, but factor the denominator as much as possible. Equals. The x plus 3's cancel, so I just have 4 times x minus 3. Let me multiply. You don't care about that into the very end. You don't care if the numerator can be factored. As a matter of fact, in general, you would want to multiply, like what I'm doing here, you'd want to multiply out. So I'd say don't worry about the numerator with these types of problems. Okay, so let me multiply the 2 in the parentheses, 4 in the parentheses. So I get 2x plus 6 plus 3 equals 4x minus 12. Combine like terms. 6 plus 3 is 9. Subtract 2x. Add 12 to both sides of your equation. And so 21 is equal to 4x minus 2x is 2x. The 2's cancel, divide both sides of your equation by 2. And so x is equal to 21 over 2. When x is 21 over 2, well, you're not dividing by 0. You'd only be dividing by 0 if x were 3 or if x were negative 3. And so this is a solution to your equation. Let me do problem number 36. Three x plus 3, 5 x minus 3 equals 4. So in this case, the least common denominator is x minus 3, x plus 3. And so the x plus 3's cancel, so you just get 3 times x minus 3. The x minus 3's cancel, so you get negative 5 times x plus 3. I have 4 times x minus 3, x plus 3, which is x squared minus 9. Let me multiply 3, negative 5, 4 inside the parentheses. And so you get 3x minus 9 minus 5x minus 15 equals 4x squared minus 36. Combine like terms. 3x minus 5x is a negative 2x. Negative 9 minus 15 is negative 24 equals 4x squared minus 36. And now, yes, I did. The x squared minus 9. What I did is I noticed that was the product of the sum and difference of two terms. And so by the special product formula, it's just x squared minus 3 squared 9. And so I just use that fact to multiply it. Or I, use distributive property. I FOILed it out. Okay. So let's add 2x. Add 24 to both sides of my equation. And so you get 4x squared plus 2x. Negative 36 plus 24 is minus 12 equals 0. Now, what I do notice here is that I can divide each of these by 2. So let me divide every term here by 2. So I get 2x squared plus x minus 6 equals 0. And let's try to factor this. And so I have 2x, x let's do this. So I have 2x squared plus 4x minus 3x is x minus 6. So it factors into 2x minus 3 and x plus 2. Set each factor to 0 and solve for x. Add 3 to both sides of your equation. Subtract 2 from both sides of my equation. And so I get 2x equals negative 3. Divide both sides of my equation by 2. So x is negative 3 over 2. Add 2 to both, subtract 2 from both sides of my equation. So x is negative 2. When x is negative 2, I'm not dividing by 0. I'd only divide by 0 if x were 3 or negative 3. So that's a solution. When x is negative 3 halves, again, I'm not dividing by 0. So that is also a solution. Oh, sorry. Sorry about that. How'd you get negative 3 halves? Oh, okay, so I set 2x minus 3 equal to 0. Stupid. That's why. Positive 3 halves. Yes. Yeah. So when x is equal to a positive 3 halves, thank you very much. When x is equal to positive 3 halves, I'm not dividing by 0. X is only, this equation, I'm only dividing by 0 when x is negative 3 or positive 3. Okay, let me do, let's say, problem 45. Yeah, let's do 45. X minus 4 over x minus 3 plus x minus 2 over x minus 3 equals x minus 3. In this case, the least common denominator is just x minus 3. And so the x minus 3's cancel, so you get x minus 4. The x minus 3's cancel, so you get x minus 2. X minus 3 times x minus 3 is, well, actually, x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is a positive 9. And so, combine like terms. X plus x is 2x. Negative 4 minus 2 is negative 6. Negative 3x minus 3x is negative 6x plus 9. Subtract 2x. Add 6 to both sides of your equation. And so you get x squared minus 8x plus 15 equals 0. Factor. It's a monic polynomial, so it factors nicely. Bring down the minus sign. Minus times plus is minus. I want to find two whole numbers whose product is 15 and whose sum is 8. 5 and 3. Set each factor to 0 and solve for x. Add 5 to both sides of your equation. And so x is equal to positive 5. Add 3 to both sides of your equation. So x is equal to 3. Well, if x is 5, I'm not divided by 0. However, if x is 3, 3 minus 3 is 0, divided by 0. So this is not a solution. This is what's called an extraneous solution. It is a solution to our technique, but it is not a solution to the original problem. So our technique is not really foolproof. It occasionally we go astray, and we get solutions that actually don't work. So I have to check in the original problem to see that the solution that I've obtained through this technique actually works. Because sometimes the solution that I obtained just doesn't work, as in this case. So you must always check to see that the solution that you obtained actually works. So any type that's solved that does not work, yes. Mm-hmm. So no. So any sort of any solution to a technique that actually is not a solution to the original problem is called extraneous. Correct. Okay. Let me do problem number 48, which is actually the same problems we did. Oops. Just a few sections ago. The literal equation. So this is actually the third time we've seen them, I think. In exercises 47 through 66, solve the equation for the specified variable. But these are harder sort of problems, so we repeat them again because they involve fractions. So in exercises 46 through 66, solve the equation for the specified variable. So A equals BC over little a. So in this case, I want to multiply both sides of my equation by the denominator, a, little a, so that I no longer have any fractions. So little a times capital A equals capital B times capital C. I want to solve for capital B, so divide both sides of my equation by capital C. So if I do that, I get that capital B is equal to little a over capital A over capital C. And that is your answer. Let me do problem number 50. Yeah, no, it does not matter. So in multiplication, it doesn't matter if you write a little times capital A, or capital A times little a, or big capital B times little b, or little b times capital B. Doesn't matter. 50. X equals, so capital X equals capital Y over capital Z plus little a. You want to solve for capital Z. And so, in this case, I'll multiply both the numerator, I'll multiply both sides of my equation, I'll multiply both sides of my equation by the least common denominator, Z, capital Z plus little a. And so, capital X times capital Z is capital X capital Z. Capital X times little a is, little a capital X. The capital Z plus little a cancels with the denominator, so you just get capital Y. You want to solve for capital Z, so subtract little a capital X, little a capital X from both sides of your equation. So you get capital X capital Z equals capital Y minus little a capital X. Divide both. You want to solve for capital Z, so divide both sides of your equation by capital X. And so capital Z is equal to capital Y minus little x, capital Z equals capital Y minus little a times capital X over capital X. And that is your solution. Let me do problem 58. V. Why do you have two X's? Because you're multiplying, you're foiling. X times Z is XZ, X times A is AX. Yes, because you're using distributive property. Okay, so V equals 1/3 pi r squared h, and you want to solve for h. Oh, by the way, of course, this is the formula for the volume of a right circular cone. And so, first off, let me multiply both sides of my equation here by 3, the denominator. And so if I do that, I get 3v equals pi r squared h. Let me divide both sides. Get a little bit of room. Cheat, I get a little extra room up here. Let me divide both sides of my equation by pi r squared in order to solve for h. And so I have that h is equal to, notice the pi r squares cancel, 3v over pi r squared. And that is your answer. Let me do problem number 66. Equals pi r plus 2h. And we'll solve for h. Okay. And so, yes, we can solve this. Well, in this case, what we're going to do first is we're going to multiply the pi r in the parentheses. And so I'm going to first multiply this pi r in the parentheses. And then I'm going to try to isolate my h. Yes. So this is the area of a I tried. Okay, so let me just see if I understand your. Can you solve this problem? Oh, pi. And what are you solving? Okay. So let me do this, and then I'll do that in 1 second. Okay. So let me multiply pi r in the parentheses. And so I have s is equal to pi r times r is r squared plus pi r times 2 is 2 pi r times h is h. I want to solve for h, so let me subtract pi r squared from both sides of my equation. So I get s minus pi r squared equals 2 pi rh. Let me divide both sides of my equation by 2 pi r. And so the 2 pi r's cancel, and you get h is equal to s minus pi r squared over 2 pi r. And that's your answer. Okay, so that really finishes off this section, but let me do that question. So it was 3a to the fourth. Okay, and you want to find the area. Okay, so example. Find the area. Find the following area. So I have a circle, and oops, you said 3a to the fourth. And I have a circle with a radius of 3a to the fourth. Okay, so I know the following, that the area of a circle is pi r squared. So therefore, the area is pi times r, 3a to the fourth squared. 3 squared is 9. A squared squared, well, 4 times 2 is 8. Therefore, the area is 9 pi a to the 8. And that is your answer. Okay? Okay, so I guess you should do a group work. No, you would not enter the value. Well, of course, you can't enter the value of pi because pi is a irrational number, and so that would take an infinite amount of time. Uh, you would only enter an approximate answer if it actually on the particular problem said to enter an approximate answer, and they would have to give you what the approximate answer is. So you would not know how to do it. Yeah. So again, right, if they said 27, use this 27, 22 over 7, or if they said 3.14 or whatever, only would you do it when they said that. Okay, so I guess let's do a group work then. So this would be section, wait 1 second. So the name is section 7.7, and the password is what the heck is the password? I didn't give it a password. Wait 1 second. Okay, password is solve. Okay, so that's what it is. Okay, so the password is solve rational equations. Okay, and I guess you should do this by tomorrow. So do this before 9 p.m. on March 27. Okay. Okay, so that really finishes off section 7 point whatever 7.7. Okay. So let me end this recording here for this section. Come up. Oh, yes, I guess this is just about the time for it. Okay. Why is this not coming up? Oh, here it is. Stop.